Good day, sir. We are from Group 2 and today we will be presenting our research on predicting e-commerce spending with statistical models. So let's dive in. So in this presentation, we'll be presenting the abstract, introduction, literature review, EDA, methods, results and discussion, limitation and future studies, and conclusion. So firstly, in the abstract, our primary objective is to predict customer spending patterns on e-commerce platforms using multiple linear regression. Key findings shows that the model performed well, achieving an R-square value of 0.9684, meaning 96.84% of the variation in spending was explained by the model. Besides, items purchased also strongly influence spending, and younger customer tends to spend more compared to older ones. Additionally, we have also observed that the geographic location also plays a role in spending behavior. However, we also noted challenges like multicollinearity and overfitting, which could affect how well the model generalizes, but future work could address this issue to improve the model generalizability. To begin, the purpose of this study is to predict customer spending in order to improve e-commerce strategies, such as marketing and resource allocation. By understanding spending behaviors, businesses can refine their targeting, inventory management, and overall decision making. The dataset we use consists of 350 customer records focusing on e-commerce customer spending behavior. It includes key variables like age, gender, days since last purchase, and items purchased, which are important in understanding spending patterns. Our goal was to develop a multiple linear regression model that can predict customer spending based on these key factors, ultimately helping e-commerce businesses make an informed decision to enhance their strategies. And now I'll pass on to Eddie to continue.
Alright, thank you, Jackie. So now let's talk about literature review. So for the attribute used, parallel research highlights three main categories, which are demographic, behavioral, and transactional data. Demographic data like age and income are essential for understanding customer segments. Behavioral data such as browsing history and product preferences provide deeper insights into spending patterns. So for instance, Shankar 2024 showed that demographic and transactional data significantly enhance model accuracy, while Nouri, Hicham, and Karim 2023 demonstrated how adding behavioral attributes improve predictive performance. So these insights shape our approach to select predictors for our models. So next, let's discuss about statistical methods. Traditional methods such as linear regression are foundational and interpretable. However, modern machine learning approaches like random forest, gradient boosting, and neural networks outperform them in accuracy. So for example, Shankar 2024 reported a 93.94% accuracy for a hyperparameter tuned random forest model. And Rahib 2024 found that assembled models combining decision tree and neural network achieved 91% of accuracy. So these advanced methods capture complex patterns but may sacrifice interpretability. So what are the key findings? The findings reveal that combining demographic, behavioral, and transactional data yields the most accurate predictions. Behavioral metrics such as browsing habits and customer satisfaction scores add significant depth. For example, Sophia 2018 emphasized the importance of browsing habits in predicting purchase cycles. These findings inform our decision to use a multiple linear regression model focusing on the most impactful predictors for customer spendings. So that's all from me. I'll pass it to Texan. Thank you.
Thank you, Eddie, and let us jump into our dataset. We get this dataset from Kaggle, and it contains 350 customers record with 11 attributes, such as age, city, total spend, and many others. We categorize this attribute to quantitative, qualitative attributes, and target variable. We pick only quantitative attributes as the independent variables since we are using multiple linear regression, and we select total spend as target variable. Before we explore the data, we need to clean it first. After we check the data, it shows that this dataset has no issue in missing duplicate values and outliers. After checking, we drop the customer ID as well, since it is not useful in statistic analysis. Next, I'll pass to Yu Heng.
Thank you, Texing. Moving on to statistics of total spend, we can know a customer's spending range from min to max. From min, we can know the customer's average spending. Median tells us the middle value of customer spending. Mode indicates how much majority of the customer spend. Standard deviation shows us how dispersed total spend is. Correlation is the relationship between variables. We are using Pearson method to calculate correlation as our selected variables are quantitative. Items purchased and average rating has very strong positive correlation with total spend. Age has strong negative correlation. Days since last purchase has moderate negative correlation. We also notice that items purchased and average rating has very strong positive correlation. We might need to remove average rating to prevent it from affecting model's performance. That's all from me, and I will pass to Chen Zhe.
Okay, thanks to Yuhan, and hello everyone. My name is Bong Chenze, and next I will discuss about how we implement the multiple linear regression in our project. So we select these four numerical variables into the model, and the variables like item purchase and average rating have high correlation between total spend, so they can provide strong information to the model. And the age and days since last purchase, although they are not being as strong, but they still can provide some information to fit the model. However, some variables assist multi-collinearity after checking the VIF values. So at the previous EDA part, we found that there's a strong correlation between item purchase and average rating. And considering that average rating has highest VIF values, so we choose to remove it. And we can see that after remove it, all VIF values are below 5, so meaning that we have handled multi-collinearity issues in this model. And this is the result of our model. So we can see that the R square value of 97% and a higher F statistic with a p-value below 0.05 means that our model predicts total spend with a great accuracy, and the overall model is highly significant. And we can look at the table. The item purchase is the strongest variable with a positive estimate of 75. So business can use this insight to encourage customers to purchase more and give some discount for large purchases. And age and days since last purchase have small negative estimate, so indicating that among younger customer and elder customer, the younger customers tend to spend more, and the customer who haven't purchased recently spend less. So, so business can use some strategies like social media campaigns to attract younger customer and inactive customers. And lastly, all the absolute t values are above 2 and the p value are below 0.05. So meaning that all variables are statistically significant. And we also can see that the item purchase has the highest t-value of 59, so means that it is the most impactful variable. So this result can give business a clear guidance on where to focus to maximize customer spending. So that's all of my part, and next I will pass to Ivan to explore about the comparison of MLR performance. Thank you.
Thank you, Chenze. And now I'll be presenting for this part. In this figure, we can see it presents the outcome of a prior study employing a multiple linear regression model to analyze total spending patterns. The model achieved a remarkably high R-square value of 0.995, signifying that 99.5% of the variance in total spending is explained by the independent variables. Moreover, the multiple linear regression model demonstrated robust statistical significance as evidenced by an F statistic of 1.504 times 10 to the power of 4 and a p-value of 0. In contrast, a study shifts the focus to exploring the relationship between customer behavior and total spending, rather than simply analyzing spending patterns across different cities. While the previous study models perform slightly better in terms of R-square and F statistic, our approach provides additional value by incorporating more quantitative metrics directly tied to customer behavior. This adds a layer of depth and relevance to our analysis, aligning it more closely with our research objective. And now I'll be passing it to Enzi.
Thank you, Ivan. My name is Enzi, and I'll be continuing on the limitations and future study of our work. So, while our model achieved an impressive R-squared value of 0.9684, showing that it fits the data exceptionally well, there are still some limitations that we need to address. First, the dataset size. With only 350 records, we run the risk of overfitting, which means our model might struggle to perform as well on larger and more diverse datasets. Imagine trying to generalize the behavior of a city based on just one neighborhood. Yeah, that's the kind of limitation we face here. Next, another challenge that we encountered was multi-collinearity, where some predictors were highly correlated with each other. And to handle this, we had to remove key variables like average rating. While this improved the model's statistical validity, it might also have removed valuable insights, like cutting a branch that has ripe fruit just because it is tangled with each other. Lastly, The linear nature of our model restricts its ability to capture more complex, non-linear interactions among variables, such as the influence of discounts or seasonal behaviors. For example, during festive seasons, customers may spend exponentially more due to promotions or holiday needs, and patterns like these cannot be fully grasped by the linear models without advanced techniques that account for these intricate dynamics. So, moving on to the future studies, we have several recommendations to tackle these limitations. First, using larger datasets, like those from Amazon or Alibaba, could provide a richer and more diverse picture of customer behavior. Second, advanced techniques like ridge or lasso regression could be used as they can handle multi-collinearity more elegantly without dropping important predictors. Third, adding more detailed predictors such as browsing history, loyalty scores, or cart abandonment rates would help the model reflect real-world behavior more accurately. And finally, exploring non-linear methods like random forests or neural networks could uncover complex patterns that linear models simply can't handle. So in short, while our model performed well, there's still room to grow. By addressing these limitations and adopting more advanced techniques, future studies could create even more robust and practical predictive models. So that's all from me, and I'll pass it on to Jiaqi. Thank you.
Thank you, Enzi. So, to summarize, the problem we tackled in the introduction was the challenges e-commerce businesses face in predicting customer spending, which affects their marketing and profitability. We have developed a multiple linear regression model that predicts spending behavior with a 96.84% accuracy. With key factors like items purchased being the strongest predictor, these insights can help businesses improve marketing and resource allocation, such as focusing on high-value customers or recognizing trends. While the model performed well, challenges like multicollinearity and dataset size remains. Besides, future research may use larger dataset and more advanced techniques like ensemble methods. In conclusion, this study shows how statistical modeling can provide valuable insights to help e-commerce businesses optimize strategies and stay competitive. That is all from our group. Thank you.